All right. Hello, everybody. So today I'll be talking about tries. And yeah, let's get right into it. So tries are a data structure that stores strings in a tree-like fashion. And the key idea of a trie is that tries have one root node, and every other node stores only one letter. And these nodes can be shared by multiple keys. And every node has a variable to indicate if it's the last character of a string. So for example, a node might have a Boolean last instance variable. So here's a trie that I made. Here's a root node, and the orange nodes indicate the last characters of a string. So quick sanity check is to ask yourselves what strings are stored in this trie. I'll give you guys, I would recommend you guys to pause the recording, and I'll go over the answer in 3, 2, 1. So hopefully we got CS61A, CS61B, CS61C, Apple, and apples. Okay. Let's move on to question 1 of the worksheet. So the first part of the question asks us to draw the trie that results from inserting hi, hello, and hey. Again, I would recommend pausing the recording, and I'll go over the answer in 3, 2, 1. So after inserting hi, hopefully we get a trie that looks something like this. We have H and the I. When we insert hello, we share the H that we inserted when we created hi, and then we have ELLO. And finally, when we insert hey, we're going to share the H between hi and hello, and then we're going to share the E that belongs to hello, and this Y is going to be by itself. But yeah, hopefully this is what we got for this part of the question. Let's move on to part 2. So this part tells us that given a dictionary of n words where the average length of the word is L, how long would it take to insert all the words into a trie? Express your answer in terms of a type asymptotic bound. Okay, again, I would recommend pausing the recording, and I'll go over the answer in 3, 2, 1. So hopefully we got theta and L. And to answer this question, let's consider what happens when we're inserting one word. So for each character in the node, there's 2 cases. We're either there's either an existing node that we can share, or we need to create a new node. And we know that creating a node takes constant time because that's just doing like node n is equal to new node. It also takes constant time to traverse through an existing node. Since the average length of the word is L, we will do L amount of work for inserting one word. And now we can consider the case when we're inserting n words. And that would just be n times L. So our runtime is going to be big theta of n L. Okay, cool. So hopefully that made sense. And let's move on to part 3 of the question. So part 3 tells us, with that same trie already containing those n words, how long would it take to check whether or not a new word of a length L was in our initial dictionary? I express the runtime in both big omega and big O notation. And because we're expressing a runtime in both big omega and big O, maybe there's a best case and a worst case scenario as a hint. And again, I'd recommend pausing this recording, and I will go over the answer in 3, 2, 1. So the runtime would be in big O of L and big omega of 1. So let's think about the best case first. Well, in the best case, the first character in the new word is not in the trie. So what if all n of our L length words start with A? And we want to check if hello is in our trie. Well, in that case, when we get to the first character, H, we'll see that there is no strings that start with an H in our trie. So at that point, we can confidently say, hey, there's no hello in this trie. In the worst case, all letters of our new word exist in that sequence inside our trie, so we need to iterate over every letter of our new word. So for example, if we had the word apple in our trie, and we wanted to check and see if, let's say, apples was in our trie, even though apples is not in the trie, what's going to happen is we still have to iterate through the A, P, P, L, E, and when we get to the E, we'll notice that there's no S, And at that point, we can say, hey, there's no apples in our try, but there is an apple. So that's kind of the idea of the worst case scenario. And I believe that's it for question 1. Yeah. So yeah, that's it for question 1, and I'll see you guys soon.